Welcome back, guys. It's Marlon again from the Natural Social Science Lab at Miami-Dade Kendall campus. Today we're going to continue with what we were talking about before. We were doing balancing reactions. Now we're going to do balancing reactions with polyatomic ions, meaning it seems like a much more difficult problem, and I'm going to show you how to keep doing it the way we've been doing it. And it will take a bit of work, and then I'm actually going to show you a trick where you balance it using these polyatomic ions, and you're going to be able to solve this entire equation much quicker. Let's go ahead and look at the system that we were doing before and try to analyze it using that method, where we simply list all the elements individually, one by one, and the last two we're going to do are hydrogen and oxygen. If you were giving me a chemical equation like this, where I have lead nitrate plus sodium hydroxide producing lead hydroxide plus sodium nitrate, I would simply start by picking any element other than hydrogen and oxygen to begin balancing. So I would pick lead, Pb for example. Then I might do something like sodium. I might go with nitrogen next. And last but not least, of course, hydrogen, and then your oxygen. So the first thing we do is we always take stock of what we initially have in our current reaction. In our current reaction, we have one molecule or one atom of lead. We have also on the right side, we have one. What about for sodium? Sodium, you see it here. There's nothing there, so you know you have a subscript of 1. Sodium on the right side, same thing. So far, not too bad. Nitrogen, a little bit trickier. Nitrogen, you see it here within the parentheses. You have to remember that you have to multiply the number outside of the parentheses times the number inside. So this is actually 2 times invisible 1 in front of the nitrogen. So this is actually 2 nitrogens on the left side. What about on the right side? On the right side, it's simply an invisible 1. What about for hydrogen? Well, hydrogen, I find it here. I simply have, at the present moment, 1 hydrogen. On the right side, you'll find it inside the parentheses again. So this would be 2 times 1 to give you 2 hydrogens on the right side. Last but not least, the oxygen. Again, you have to be very careful. For example, here we have a 3 inside the parentheses. So it's actually 2 times 3 to give you 6, but you have to add the other 1 oxygen here. So this actually gives you a total of 7 oxygens, but in the format of 6 plus 1. You cannot forget to put these parentheses. If you don't put this, a lot of students will get the total mixed up later on. So make sure you make a note of how you came up with this total oxygens. On the right side, we also have a similar situation where we have 2 times the invisible coefficient of 1 on the inside of the parentheses, plus another 3. So we actually have a grand total of 5 oxygens, and that's in a format of 2 plus 3. Okay, so what do we do first? We analyze our first element, but there's nothing need to be done. It's completely balanced already. Go on to the second one, balanced. Third element, nitrogen. Now we see we have an issue. We have 2 on the left and 1 on the right. So I need to balance the right side. How am I going to go ahead and do that? Well, I find nitrogen on the right side. It's over here. And I need to put a coefficient that when I multiply it times my subscript will give me a total of 2. So in this particular case, it would be 2 times the subscript of 1 to give you 2 nitrogens. Now, what's one of the most important rules? As soon as you put a coefficient, you have to remember that you have to distribute your coefficients. You have to multiply it times sodium, times nitrogen, and last but not least, times your oxygen. And you have to take restock of your elements. So now I have 2 sodiums, which also messes up the balancing, which we'll come back to. And now, where I initially had 3 oxygens, I now have 2 times 3 for a total of 6, plus the original 2, gives me 8 oxygens in the current moment. So once you've checked this one off, which it's already done, you're going to have to come back up to sodium. So you come back up and you see that you have 2 on the right, only 1 on the left. How am I going to go ahead and fix that? Well, let's find sodium on the left side. Here it is. It's got a subscript of 1. So if I put a coefficient of 2 times that 1, now I have 2 sodiums on the left side. So this is balanced. The only problem is I have to distribute my coefficient to each element. So my oxygens will also be affected. Now I have 2 times where there was 1, there's now 2. So this is actually 6 plus 2 for a total of 8 currently. What else is affected? My hydrogens. Where initially I had 1, I now have 2 times 1 to give me 2. And look what happened. Now we have 1 lead on both sides, 2 sodiums, 2 nitrogens, 2 hydrogens, so that's balanced, and your oxygens are actually balanced. You have 8 on the left and 8 on the right. The only thing you have to do now is you make sure you put a 1 on the blank coefficient spots. So we'll put a 1 there, and we'll put a 1 there in case it asks you for the sum of the coefficients. It would be 3 for a total of 6. So that took a little bit of work. We had to remember to go back, up, and then to proceed downward. Now I'm going to show you the method where you can solve this much quicker if you were to simply analyze this, not by individual elements, but by remembering what your polyatomics are.